This week on the show, we covered the design and implementation of NetBSD's rc.d system. The first impressions of Project Trident 18.12 are covered. We also have pixie booting of a FreeBSD disk image for you, middle mouse button pasting, as well as NetBSD gains hardware-accelerated virtualization in this week's episode of BSD Now. BSD Now, episode 287, rc.d in NetBSD, recorded on the 27th of February 2019. Hello, I'm your host, Benedict Reuschling.
And I'm Alan Jude.
And we should get right into our headlines without any delay, because we have the design and implementation of, wait for it, the NetBSD rc.d system.
Yeah, so this is a paper from Usenix 2001, but it talks about the rc.d system that shipped in NetBSD 1.5 in the year 2000. But it's, the heritage of what we have now, so it's worth taking, understanding why it was built the way it was. Mm-hmm. So the abstract starts with, in this paper, I covered the design and implementation of the rc.d system startup mechanism in NetBSD 1.5. which replaces the monolithic etcrc startup file inherited from 4.4BSD. Topics covered include a history of various Unix startup mechanism, including what NetBSD did prior to 1.5, the design considerations that evolved over the 6 years of discussion, implementation details, and examination of the human issues that occurred during the design and implementation, as well as future directions for the system.
Okay.
So then the introduction goes on with NetBSD recently converted from a traditional 4.4BSD monolithic etcrc startup script to an etcrc.d mechanism. So if you're not quite clear what that means, it meant that etcrc was one giant shell script, whereas with the rc.d mechanism, you have a directory with individual shell scripts for each service. Then they kind of explain that. So the rc.d mechanism, where there's a separate script to manage each service or daemon, and these scripts are executed in a specific order at system boot. This paper covers the motivations, design, and implementation of this rc.d system, from the history of what NetBSD had before to the system that shipped in NetBSD 1.5 in December 2000, as well as some future direction.
Mm-hmm.
The changes were contentious and generated some of the liveliest discussion about any feature change ever made in NetBSD. Part of these discussions was covered to provide insight into some of the design and implementation decisions. So they talk a little bit about the history of what was before. There's a great diversity in system startup mechanisms used in the various Unix variants. A few of these or more pertinent schemes are detailed below. In NetBSD, as it was derived from 4.4BSD, it follows what a description of the latter method is relevant. They also talk about the Solaris startup method and the System 5 startup method. So there's, in 4.4BSD, it was a simple startup scheme. When booting multi-user, the kernel runs init, which is sbin init, which spawns a shell and runs etcrc. And that contains commands to check the file system, mount the disks, start up everything, etc. And then at the end, there was rc.local, which allowed you to add extra shell script to do whatever you needed at startup. Whereas with Solaris is the most common of the System 5 variants and serves as a good reference implementation of System 5 init.d mechanism as implemented in System 5 Release 4. And it talks about the run levels system.
Yes, yeah. There it is.
And then looking at older versions of NetBSD and how they worked. Then they talk about some of the design considerations. First, they started by listing all the problems with the old system, the requirements for the new system, including figuring out some kind of dependency ordering.
Problems some try to figure out today still for other run systems like that.
In particular, they wanted to not have to bloat the bin and sbin directories. So because the rc.d stuff is going to run early before you've mounted other file systems, when /usr is usually one of those file systems, it means you don't have access to usr bin and usr sbin. So the programs you're going to use in these scripts have to exist in the base, the root bin and sbin directories. So you have to be careful, not to depend on certain applications that might not be available.
Yeah.
And then I talk about manipulation of individual services, support for third-party scripts, and so on. When you install packages, you want it to be able to plug into the system. How you're going to maintain rc.conf, promoting code reuse so that we don't have a lot of copy pasta, handling shutting down services, and one of their design considerations was avoiding mandatory run levels, which I'm glad they did.
Yeah, otherwise we have to run through those.
Yeah. Some of the other issues, how to improve the configuration, the implementation and the aftermath, the human issues they ran into, including the use of magic functions and, what people said about the proposed changes.
Oh, like this one. Switching from etc/rc is not the BSD way. Remember some other discussions going on recently about, switching from rc.d to some other system like that? And I guess some of the arguments are similar to way back when.
Yep. Anyway, the paper goes into a great deal about all this, including how RC order works for actually figuring out the order. And they talk about their future work. They say, I'd like to implement functionality to allow you to start or shut down services from service A to service B. This allows you to start in single user mode and then start up enough to, say, get networking running, or start all services until just before you get the multi-user login, or, something between network running and database start, basically being able to start a range of services. So if you're having a problem with the database startup, you say, do everything up to that, and then when you get to that phase, stop and let me interact with it. I don't know how useful that is, but interesting. And it also says, I encourage other systems that are still using a monolithic RC and who would like to resolve some of these similar issues to consider this work, and would be willing to liaise with maintainers of these systems to ensure code reuse as much as possible. And then it includes the CVS web interface where you could see the code back in the day. And interestingly, their reference material is mostly the design and implementation of the 4.4 BSD operating system and installing and operating 4.4 BSD Unix by Kirk McCusick, Keith Bostic, and Mike Carls, and so on.
Yep. Very nice. Having this
some emails, including one from Robert Ells. Anyway,
yes.
If you're interested in the rc.d system, it's worth the read.
All right. That's cool. And we also have the first impressions of Project Trident 18.12 over at DistroWatch. They had a closer look at that. And they start with the first impressions that Project Trident, hereafter referred to as Trident, is a desktop operating system based on TrueOS. Trident takes the rolling base platform of TrueOS, which is in turn based on FreeBSD development branch, and combines it with the Lumina desktop environment. They talk about the installation, of course. The debut release of Trident is available as a 4.1 gigabyte download that can be burned to a disk or transferred to a USB thumb drive. Booting from the Trident media brings up a graphical interface and automatically launches a project system installer. Down the left side of the display, there are buttons we can click to show hardware information and configuration options. These buttons let us know if our wireless card and video card are compatible with Trident and give us a chance to change our preferred language and keyboard layout. And at the bottom of the screen, we find buttons that will open a terminal or shut down the computer. So here's a little screenshot. And the center of the screen is occupied by a series of pages offering configuration options. They begin by providing the time and our time zone. The next screen asks which disk we should place Trident on, and some other information. Of course, you want to set up ZFS in that regard. And then it walks you through a series of other screens to set up the basic system so that nothing is surprising there. If you have done FreeBSD installations, I guess this is fairly familiar. And the entire process of setting up Trident took them a little bit under 15 minutes. And here, after the reboot, is the login screen. So early impressions are that Trident boots to a graphical login screen where we can sign into the Lumina desktop or a minimal Fluxbox session. Lumina, by default, uses Fluxbox as its window manager. Lumina Desktop places its panel along the bottom of the screen, and an application menu sits in the bottom left corner. On the desktop, we find icons for opening the software manager, launching the Falcon web browser, running the VLC media player, opening the control panel, and adjusting the Lumina theme. And they talk a bit about the hardware that they're using. They tried running Trident on a workstation and in the VirtualBox environment. Trident performed well on the physical workstation, whereas the hardware was all detected, apart from a USB wireless card they tested later in the trial. Performance was fairly smooth and the system responsive. When running in VirtualBox, Trident would function, but with some limitations. For example, the system does not detect the available screen resolution, making the desktop quite small. But you can fix that by resizing the VirtualBox window and then manually killing the Fluxbox process. So next time it comes up, it detects the bigger screen. Okay, then they looked at applications. They said that Trident does not include a lot of applications in its default install. The Falcon web browser and VLC media players were included. There were also a number of Lumina-specific applications, such as the file manager, text editor, PDF viewer, and screenshot tool. There's also a Lumina media player and some configuration tools, which they'll cover in the rest of the article a bit later. But otherwise, the application menu is minimal. And then basically, you can look at managing or installing the software from the software installation manager. And then you can everything installed from the App Cafe. From there, you can pretty much install everything that's available. And it's divided into 3 tabs, the App Cafe. Browse, installed, and pending, so you can see your progress. And the Browse tab shows categories of software and features in the search box, quite convenient. And then they have a bit about settings. The Trident system comes with a control panel. From there, you can manage the boot environments, browse and revoke SSL keys, and manage the firewall, disable background services, and all these other things. So from convenient location where you can set all these things. Then they had some other observations that by default, Trident uses a dark theme, and personally they think it looks nice. However, they wanted to try some lighter themes as well, like it's winter here, they write, where they live, and they wanted some more light in their life. And they tried a lighter theme, and they appealed to them, but a side effect was that some button icons became invisible when the lighter theme was used. Oh, white on white. Okay, yeah. Yeah, that happens, but you can also change the icons. So yeah, that's pretty much it. And they conclude with that they have a lot of mixed feelings and impressions when it comes to Trident. On the one hand, the operating system has some great technology under the hood. It has cutting-edge packages from the FreeBSD ecosystem, easy access to ZFS, boot environments, and lots of open source packages. Hardware support, at least on the physical workstation they tried, was solid, and the Lumina desktop is flexible. However, on the other side, there were a lot of problems they ran into during this trial. Some of them are matters of taste or style. The installer looks unusually crude, for example, and the mixed icon styles weren't appealing. Switching themes was also some problematic because some icons and toolbars disappeared, and there are not functional issues but presentation ones. Lumina has come a long way, they write, and is highly flexible, and they like the available alternative widgets for desktop elements. This is useful because Lumina's weakest link on Trident seems to be its default, and it has some trouble with the start application menu, and they think some work to polish the initial impression would be helpful. Okay, but overall, not so bad for people who haven't tried it out.
Yeah, Trident is still pretty new. They're trying to do a lot of things at once. So the fact that if you switch to a light theme, some of the default icons that are basically transparent and white to show up nice on a dark theme are practically invisible is something that would need to be worked on.
Yeah, but if you want to introduce people to a desktop, FreeBSD or a variation of it, then that's a good start you can do in Project Trident. So, news roundup for this week starts with PXE booting of a FreeBSD disk image.
So this is from our friend Olivier Couchard-Lebay, and he says, I had to set up a regression and network performance lab. This lab will be managed by a Jenkins instance, but the first step is to understand how to boot a FreeBSD disk via PXE. This article explains a simple way of doing it. For information, all these steps were done using two PC Engine APU2s updated to the latest BIOS, so they have iPXE support. So it's a headless, so serial port only. This could also be done with IPMI serial over LAN if you had, say, regular x86 hardware. So they start off with the big picture. He says, before explaining all the steps and command lines, here's an image of the full process. So you can see step 1 is you have the iPXE ROM, which is going to do a TFTP get of the PXE boot stuff. And you see it gets that. And then once we have PXE boot, it's going to use the root-path to know where to load the kernel from and tempfs. And instead of loading a full disk image, it's going to load the image-mini root, which is a 10 megabyte version of the base system that's just etc rc, all the tools from bin, sbin, and userbin. Once you have that, then you can fetch the large 2 gigabyte image using FTP instead of TFTP, which will be much faster. Because TFTP is UDP and is doing a separate get for each small block and so on, it's never very fast. So doing 10 megabytes that way and doing the 2 gigabytes via HTTP or FTP makes a lot more sense.
Yeah.
So first you want to create an image-mini root and an image.txz. And you can use pudrere image command to do that. Then you want to set up a DHCP server. They use DNS mask. A TFTP server, the one built into FreeBSD, is fine. An FTP server, also the built-in one, is fine. Then you populate the TFTP and FTP servers, set up the DHCP server, and then test the results. So to create the image, install pudrere, configure it. Because he's doing this on an APU2, he didn't use ZFS. Create a pudrere jail. So since he wanted 12.0 release, he was able to just download the images instead of having to compile, which probably saves a lot of time when you're using an APU2. Configure custom configuration files to make the image you want, and then use the pudrere image to make a mini root and main file system. So you can see here, he put no ZFS into his pudrere.conf, used download.freebsd.org as the location to get stuff from, created a 12 AMD64 jail, created his overlay file, and put his loader.conf in it so that the image that gets generated will have his loader.conf in it. Same for a couple other files, like setting his mini root overlay directory. Sticking the shell script into it, and so on. Then he configured his TFTP server, tested it to make sure it would give him the right file, set up his FTP server, and put his full system image in it. Then set up the DHCP server to have a range of IPs to give out, setting the options of where the TFTP server is going to be, tell it what file to TFTP boot, and then setting his options like the root path to get the root file system from, then enable and start DNS mask. So then watching the serial console, he boots the second APU2, and you can see it starts iPXE, gets the DHCP information, then gets told, here's the IP address and the file to get over TFTP, does that over TFTP, runs it, that reads loader.conf, does the stuff, loads the kernel and tempfs, loads the mini root, then we boot that. Then we mount the root file system off the memory disk that we populated with that mini root. And then once we pull down the full system image, we'll have a root file system that's 2 gigs.
Okay. Yeah, don't get scared by the cannot open etcfs tab.
It's just because he didn't have one, because he only has a root file system. But with this, if he teaches Jenkins to use Poudre image or some things, or to generate the images itself, then he can automatically produce newer versions of his test version of FreeBSD, and then just reboot one of his bigger machines that he's going to have access to, and it will start running the newer version, and then he can do his network tests. With something like this set up nice, he could very quickly try different versions of FreeBSD with, say, different patches and see how it affects performance on a bunch of different sizes of machine.
Yeah, the feedback loop is much quicker this way.
Yes, if you can literally just say, here's 5 different versions of FreeBSD, and here's 5 different machines. Go run every patch on every machine. Also, for this patch, try these 3 different values for the sysctl. Suddenly you have 75 or more combinations to work through, and you just let it run and come back later and you get the results.
Yeah, that's nice.
Yeah.
And yeah, so the big picture there shows you each step and what it's...
yeah, it's got a bit of explanation about some of the options, what they're for and why. But it lets you summarize just how the boot process actually works. Right? The Pixie client boots up, talks to the DHCP server, then uses TFTP and gets these files. Then one of those files is Pixie boot, which you now run, and it uses a little bit more TFTP to get some files. Then the kernel and the mini root talk to the TFTP server, get the full image, mount that as a root file system, and you're done. And you actually see what he's doing here is in the mini root, he's replacing etc.rc with a small script that basically fetches over FTP the big image, untars it, and then switches to that device as the root file system, and then does reboot-r, which is reroute, which basically stops userland and starts userland again with a different root system without having to reload the kernel.
That's also nice.
Yeah. So it's a very straightforward way to only have to TFTP a 10 megabyte image, which is basically just enough of a system to fetch a 2 gigabyte image over a faster protocol than TFTP.
Yeah. Okay, very nice. And we also have why I like middle mouse button paste in Xterm so much. This is from Chris Siebenmann, which blocks a lot, and we'll cover that as well because we found some interesting stuff in there. Pretty much each time we find something new. Mm-hmm. And in this, we have, so he refers in this blog post an earlier entry from about how touchpads are not mice. And Moose there that one of the things he should do on his laptop was ensure that he had a keyboard binding for paste, since the middle mouse button is one of the harder multi-finger gestures to land on a touchpad. And recently, Kurt Moshietschuk, sorry, can't get the name properly, and recently left a comment there where they said, Shift Insert is a keyboard equivalent for paste that is in default Xterm, at least OpenBSD's Xterm, and PuTTY on Windows 2, and uses that most of the time now that that seems less trigger happy than right-click paste. So this sparked some thoughts in Chris, because he can't imagine giving up middle mouse paste if he has a real choice. he had earlier seen shift insert mentioned in other commentary on an entry, and so have tried a bit to use it on his laptop, and it hasn't really felt great even there. On desktops, it's even less appealing. So he tried shift insert out there to confirm that it did work in a set of wacky X resources.
Yeah, this shift insert is not a great finger reachy combination. It's slightly better on my laptop maybe than my regular keyboard. And no, it's actually better on my regular keyboard than my laptop. Luckily, my laptop has a middle mouse button still, even though it has a trackpad.
Mm-hmm. So there, in thinking about why this is, he came to the obvious realization about why all of this is the case. He likes middle mouse button paste in normal usage because it's so convenient. Because almost all of the time his hand is already on the mouse, and the reason his hand is already on the mouse is because he's just used the mouse to shift focus to the window and wanted to paste into. So even on this laptop, his right hand is usually away from the keyboard as he moves the mouse pointer to the touchpad, making shift insert at least somewhat awkward, with the exception that proves the rule is his D menu and completely keyboard bound or keyboard driven, and when he brings it up, Control Y to paste the current X selection is completely natural. So he expects that people would use the keyboard to change window focus, have a pretty different experience here, whatever they're using a full keyboard-driven window manager for a simple one where they use Alt-Tab or the equivalent to select through the windows. And in his laptop Cinnamon setup, this has support for Alt-Tab window switching, so perhaps it would try to use it more. On the other hand, making the text selection he's copying is generally going to involve the mouse or the touchpad, not even on his laptop.
Yeah. Highlighting and copying and pasting text and stuff is much more fun with a real mouse than with a touchpad. The terminal thing I use, the default Qt one, Q terminal, I like the keyboard shortcuts I have where I can shift side arrows and so on to switch between the tabs, or I think it's like Alt-Shift to reorder the tabs and stuff. I've got a lot of keyboard combinations so I can avoid using the mouse somewhat, but for copying and pasting, the mouse is still the thing. And yes, I would die without middle mouse button. And it's actually started to become a problem as I do my work every day on a FreeBSD machine. The odd time I've been using my old laptop with Windows on it to connect to a VPN to work on a customer's thing. And that's having to use Windows because of the VPN software. And I press middle click and nothing happens in Windows. Because in PuTTY they made it right click. I have to look in the config and see if I can change that because it's starting to drive me nuts.
Yeah, and then you're back on your Mac and it's even different there.
Well, yes, I've still not got used to the Mac where option and control are sometimes opposite and sometimes not. I think the one I miss the most is like control arrow key to jump one word at a time through text.
Yeah, you can remap that. But it's
right,
by default.
And I know there's a way to do it on Mac, but I just don't know all the Mac shortcuts. And it's not really helped by the fact that I only use my Mac when I'm on the road. I never use it at home, so...
Yeah, less practice. Yeah,
exactly. It's never going to be my primary system, so I'd rather keep working on FreeBSD every day.
Yeah. So yeah, Chris has a couple of good points here, and maybe someone out there knows a solution for him, and we can cover that next time. And oh, what wonderful news. NetBSD also gains hardware-accelerated virtualization. We covered this a little bit in the past, but now it's official.
Two separate things, which might be confusing people. There's the NVMe, which is basically NetBSD writing their own hypervisor from scratch. And then there's the Intel HAXM, which was ported to NetBSD. Which basically ends up using QEMU and reusing a lot of existing code. There are advantages and disadvantages to both. Originally, the disadvantage to NVMe was it was AMD only. But about 3 days after we did the Haxum story, they landed support for Intel on NVMe. So NVMM is more analogous to VMM/VMD on OpenBSD or Beehive, whereas the Haxum thing is a hardware acceleration layer for QEMU, which is kind of a bit more like KVM, but not quite the same.
Okay.
But yes, so NVMM provides hardware accelerated virtualization support for NetBSD. It's made of mostly machine-independent front-end to which machine-dependent backends can be plugged. The virtualization API is shipped via libnvmm and allows to easily create and manage multiple virtual machines via the NVMM system. 2 additional components are shipped as demonstrators, ToyVirt and SmallKern. The former is a toy virtualizer, which executes in a VM the 64-bit ELF binary given as an argument, and the latter is an example of one such binary. So you can see that they're setting this up so that you could use it in more of a microkernel type instance. So it's a virtualizer, hypervisor, but one of the things you could do with it is run a really small operating system, which is say the bits of a kernel you need and your application compiled together into one binary. So basically, a kernel that is your application, your application with the bits of the OS that your application uses grafted into its binary, and it would just run as the only program in the virtual machine, which has some advantages and so on.
Okay.
Actually, hold on. Apparently, this VMM stuff has some QEMU bits or something. So once they compile libv or NVMM, yes, apparently you can actually use NVMM as an accelerator for QEMU as well.
Okay, yeah.
So now NetBSD has 2 accelerators for QEMU. And I kind of want to see them benchmarked off each other.
Next to each other, yeah. One side by side.
And the 2 backends supported for NVMM right now are x86 SVM for AMD and x86 VMX for Intel.
So yeah, NetBSD
so it seems that NVMM is not as much like Beehive and VMD as I thought, because it's mostly just the back-end bits and less of the front-end, and it just relies on QEMU as the front-end.
So yeah.
Which is interesting because I know there have been talk at various points about trying to do something like that for both VMD and Beehive.
Yes, so I guess NetBSD has also entered the virtualization game, not just with Zen, which they had for a long time now, but also now with these 2.
Mm-hmm.
So, time for BSD Bits this week. We start with Solo BSD 19.02. Stable has been released.
Yep. So they've updated a bunch of packages, including cpdupe, DMI decode, IPMI tool, rsync, smartmon tool, htop, etc. So if you need a small diagnostic CD, the ISO's barely 200 megabytes and has most of the tools you would need to figure out what's going on.
Mm-hmm. And the next is, as we covered in our previous section, the Project Trident 18.12.5-U5 is available. 18.12, that's update 5. And that gives us a bit more updates in the graphical system update utility. It has a new version now with a couple of new features. When starting these updates, there will now be a prompt about whether to perform a full update, like forcibly resync your system with the versions of packages in the repo, or do the option takes a bit longer, but it's very useful if you need to do that. And the second thing is that package repository selection options are now available as well. Cool. And the third thing they list is that the backend sysup utility has also been updated and fixes the startup delays that were being seen with that utility.
Cool. And they've also apparently fixed their Myth TV package. So if you're using your TrueOS machine for your TV stuff, then there you go.
It's back.
Next up, an update from our favorite author, Michael W. Lucas and his gleefully malicious books.
Yep, he's busy writing, and one of it seems becoming close to finish. FreeBSD Mastery Jails is out for tech review. He writes, reviews are due back on the 25th, so he can get it to the compy editor before he leaves for a writing conference on the 28th. Right now, the manuscript is laying fallow, and he's not allowed to look at it. Yeah. Next week, he needs to be able to read what he actually wrote instead of what he thinks he wrote. Yeah, that can be a difference.
You do have to put the whole thing down for a while and let it fall out of your short-term memory.
Don't look at it.
And then read it with fresh eyes.
Mm-hmm. But that means he needs something else to work on. And he scheduled a bunch of chores and stuff this week, plus fixing the women's shelter computer lab. So it's not a good week to buckle down and finish Terrapin Sky Tango. But he had enough time to dig into outlining his next tech book, drum roll, a new pseudo mastery. Why is that?
This was originally prompted by various publishing industry neepery reasons. But I've dug into the docs. It turns out that a second edition is warranted. There's a lot of new options. Features that I didn't cover in the first edition have grown more knobs and more merit for a mention. Things like CVS to LDIF is no longer a thing, thankfully. And Sun's iPlanet LDAP server has been eaten by the beast and rebranded as the Oracle Damnation Directory or something like that. Fortunately, the LDAP stuff hasn't changed much. My LDAP setup is much smaller than when I wrote the first edition. The hard part is, of course, picking cover art. I always post requests for suggestions on Twitter and Mastodon, and I can count on 3 responses.
Okay.
Munch's The Scream, a number of paintings by Bosch. I adore Bosch. His work will be used as a wraparound for the Ansible for artisan and legacy heterogeneous systems networks, which has moved towards the top of my queue, but isn't ripe yet. And he says that wraparound will go around the inside of the dust cover jacket, by the way. And it's going to be glamorous. And, of course, dogs playing poker because Americans.
Yeah, and so that's probably going to be it. And, yeah, he talks a bit more about the friend in need and cheating, but you can read the rest of this blog post on your own. Next, we have Make Sanitizer, bug detector software integration with the NetBSD userland. So they're doing a lot of stuff in this area, I need to say.
Yeah, so basically they have TSAN, which is the thread sanitizer for finding bugs in threading. MSAN, which finds uninitialized memory reads, so reading from a memory that you've never actually written to, and so we'll have just random leftovers in it. ASAN, which is the address sanitizer, and that's finding where you're using a pointer that you were not meant to use, basically, when you're done some arithmetic or something and ended up at an address that isn't valid. And UBSAN, which is where your code is using undefined behavior, where it might work right now, but it might randomly change later when compilers change, because that's not a defined behavior. The compiler could change at any time. So they have the MK sanitizers switch, which when turned on, will start using all of these sanitizers on your code. He says, sanitizers usually introduce a relatively small overhead of about 2x compared to something like Valgrind, which is 20x. The portability is decent, as the sanitizers don't depend heavily on CPU architecture. And in the UBSAN case, they basically work on everything, including a VAX. So in the Valgrind case, the portability is extremely dependent on the kernel and the CPU, thus making this diagnostic tool very difficult to port to different platforms, whereas ASAN, MSAN, TSAN require large addressable memory due to their design. And that means that obviously MSAN and TSAN really only make sense on 64-bit architectures, because if you're going to keep track of all the memory and address accesses and stuff, you're going to need a bunch of memory. But the main purpose in enabling this on the whole system is obviously bug detection and assuring correctness, especially if you have high security demands, and auxiliary feature for fuzzing. If you turn all this on while you're fuzzing, you might actually more easily identify where the problems are. Anyway, if you're interested in applying sanitizers to the whole user land and so on, you should read the rest of the post.
Mm-hmm.
They've a series of 35 patches attached to the post.
Okay, yeah, they're making a lot of progress in this area, which is good because it benefits also not just NetBSD but other application software, and that gets ported over to other operating systems. But we also have darn kids nowadays. Back in my day, we drew root symbols like normal people.
So this is a vehicle with a Unix Guru license plate, and somebody has written Windows rules on the back window in the snow. And a couple of comments here saying things like, it's cool, that message is about as stable as Windows, because someone else says, like the wipe of a hard drive, Windows will be wiped away very soon.
Yeah, quickly and easily.
Although somebody else says, I'm just glad some kids care enough about operating systems to actually try to troll you. At least they know what Unix is, right?
Yeah, at least a little bit. Cool. I like that picture.
Mm-hmm.
And also we have, we want to re-mention it, shell check. It's over at shellcheck.net where you can enter your shell command line and then it will check for bugs in your shell scripts.
Yeah, so you just paste the shell script in and then you say, hey, right here, you didn't quote this. And if this happens to have spaces in the output, it might not do what you expect. Here, you should double quote to prevent spaces or stars or question marks or anything like that in the files from being interpreted and not doing exactly what you expect.
I should give this to my students because they do a lot of things like a space equals space 1, for example. And I say, I told you no spaces in assignments. And yeah.
Well, it's not so much that one. This really finds the trickier ones. Like you did a thing that's going to match 2 files, and the space is going to mean you actually treat this as 2 arguments, not 1, and it's going to not necessarily do what you want.
Yep. Well, yeah, it has a couple of things like, did you mean this, or did you try maybe rewriting this in that form?
Put the quotes here, or use this instead of that.
Well, nice little thing to help you in your endeavors to make a shell script more legible. And last but not least is Old School Sean, a story or a history of Unix over at YouTube.
Yep, it's a shortish YouTube video, but giving a basic history of Unix in 8.5 minutes.
Oh, that's a challenge, yeah.
Yes. So, on to the questions.
Yeah. The first one is Alice about OpenBSD, FreeNAS, and OpenZFS questions. Starting like this. Greeting, BSD gents. Your show has helped me quite a bit over the years. Oh, that's great to hear. I've gone from being a knucklehead project manager to paying a gig as a Linux admin/engineer and a side job as a FreeBSD admin. Still a knucklehead though. My Google foo, or rather Dr. GoDo, has failed me at finding performance tuning tips for MariaDB as a data store. Did we have that already?
I remember reading the question, but I don't remember if it was on the show or if I just answered the email.
Yeah, could be. So MariaDB docs only have some general suggestions, which aren't super helpful in tuning for small sites in jails on UFS. And he did notice that there are 1 or 2 packages in the ports collection that can make suggestions on performance tuning, but wasn't sure if that they're accurate. Or can you give us an idea of how to start?
In the OpenZFS wiki, there are some basic tuning guidelines for MySQL, which is basically will apply the same to MariaDB. Although those are for on top of ZFS, and it sounds like you're using UFS, in which case there's not much. The defaults should work just fine. And again, I think we did answer this question before. It really depends on where the bottleneck is, what knobs you should be trying to tune. So it's a matter of looking at it and figuring out what part is being slow and then working on it.
Yeah.
But the best source for documentation on kernel tunables, sysctl-d, the handbook and the man page. There's a specific man page called man tuning, although it could really use some love as far as updating and so on.
Bring it to modern times.
Yeah. The again, for ZFS, there's a section of the ZFS handbook that describes a bunch of the tuning parameters, although it's missing some of the newer ones, and it might actually have a couple that have been renamed or built differently. And no, I don't get tired of answering ZFS questions.
Yeah,
Recently
otherwise
joined more ZFS chat rooms.
Oh, okay. Like you wouldn't already be listening to a couple of them.
Well, it's interesting to get to talk to more people that are actually looking at the code rather than just using it too.
Sure. Okay, so thanks for that question, which might have been a repeat, but the next one definitely isn't. By Malcolm about thoughts on PGSQL plus ZFS thread. So asking us, could you provide some thoughts on the claims of Ryan about IOPS growing his log n in a single update to Postgres when running on ZFS? So their claim seems to be not that ZFS is bad, but that running it on your master is going to explode in IOPS consumption, which can get very expensive and slow on cloud services such as AWS, and provides two links for us.
So yeah, in general, ZFS has to do more work for every write than a different file system. But the IOPS explosion isn't going to be necessarily the same as you think. Because it's copy on write, we're not going to reach back and write the updated metadata in all the different places. It's going to batch it all up together and write it all at once as part of the syncing process. So it's really, as long as you have enough free space, going to be one big linear write. So it's not going to be as IOPS intensive for the fact that you have to update a bunch of other metadata during every write. Now, there are things you can do. There's a dataset property called redundant metadata, and its default value is all, but it can be changed to most, specifically for databases, because if you're doing small writes like you would for a Postgres or MariaDB dataset, you don't want to end up writing more metadata than you wrote data. So most metadata in ZFS is written 2 or 3 times. Basically, when you have copies equals 1, metadata automatically has copies equals 2, or basically copies equals your number plus 1. And then important dataset level metadata is copies plus 2. Now the max copies is still 3. So if you set copies equals 2, it'll go from 1, 2, 3 to 2, 3, 3, or 3, 3, 3. But so turning redundant metadata to most will reduce some of the additional writes. For the reads and stuff, ideally your entire database working set should fit in memory. And if the ARC is caching everything, then there's no extra IOPS executed against your disk except for the writes, because all the reads can be served from the compressed ARC in memory. So theoretically, it would grow the number of IOPS, but because of the batching and consolidation that it's going to do, most of those IOPS will go out as one bigger IOP rather than a bunch of small IOPS, and therefore not cause as bad a performance penalty as you think. But in general, yes, ZFS has to do more work under the hood to keep a database happy. The advantage, theoretically, ZFS shouldn't ever be faster than some other file system, because every other file system is going to be doing less work, and so should be able to do it faster. ZFS is also guaranteeing that your data is not going to get hosed no matter what. Part of that might be tuning Postgres in particular, telling it that it doesn't need to do full page writes and that it doesn't need to do as much double writing and so on, because it can trust ZFS to handle that for it. So most of ZFS is going to hide most of this theoretical problem, and there's some tuning in ZFS and Postgres you can do. Again, those are described on the OpenZFS wiki to obviate that and possibly make it actually make Postgres ask ZFS not to do as much work, and therefore give it a more reasonable performance compared to some other file system. Always ZFS is going to give you a safer environment, but that does have a cost, but you can mitigate most of that cost.
Yeah, so it shouldn't be too heavy.
Yeah. Yes, because theoretically when you think, all right, so when I write this block, I'm going to have to update its metadata and then all the way up the tree to the top. And that, if you were overwriting, that would be writing to a bunch of different places because all that data is different ages. But because it's copy on write and kind of log style, you're going to write it all at the end of the drive, basically, or at the end of where the pointer or the head is. And so you're just going to write one big linear write unless you have no available free space, and then you're going to have to break it up a bit. But, the solution to that is have some more free space. But in general, that way, it could actually end up saving you money over a traditional file system because all those writes will be batched as bigger IOPS instead of updating a bunch of data and doing a lot of random writes. Basically, in ZFS, you never have random writes. All writes are sequential writes because you just write all the new data into the largest block of contiguous free space you can find that'll fit it. That's one of the advantages of ZFS.
Yeah, one of them. If only that would be available in other file systems, but ZFS has much more. Okay, let's hope that answered your question. And the last one for today is coming from Brad about boot environments in FreeBSD. It goes like this. Hi, Alan, JT, and Benedict. This is a follow-up to a conversation he had with Alan on IRC. He switched his laptop over to FreeBSD 12.0 release and noticed that they had a new tool, BECTL, and creates a boot environment out of the box. So I took a few minutes to write a script that manually create a boot environment. If FreeBSD update fetch indicates that there are new kernel components to be installed, and in effect, it creates and activates a new boot environment, instructs you to reboot into it and run FreeBSD update install and reboot again. And he hasn't figured out yet how to bolt the script into the plumbing of FreeBSD to automate some of this stuff like TrueOS did. In speaking to Alan, he pointed out that he didn't like the fact that rolling back to a previous boot environment causes anything you have installed or changes to config files would be lost. He started rooting around in the boot environment and noticed that user local is included in the boot environment. If I understood the concept, the boot environment is supposed to be decoupled from the user data, like /home, and the userland applications, like /user local. So the question is whether moving user local to its own data set makes sense, or would that keep rolling back to a previous boot environment from whacking changes? Or is this a bug-worthy item?
So the reason user local is included in the boot environment is so that you can use a boot environment to undo a bad package upgrade.
Yep.
So you can decide that you want user local separate and to manage snapshots of it separately or something. But for the default on FreeBSD is very much done on purpose. And it doesn't really cover the problem of if you do your updates this way, where you update the new boot environment and then boot into it at some later date, like when you change something in etc, which is always going to be part of the boot environment, after FreeBSD update is run on the new boot environment, you're going to have this disconnect there. That's why the way I prefer to do it is when your FreeBSD fetch there finds an update, it would snapshot and create a boot environment and just call it, before update 7. And then you would update the running environment with the new version and then reboot into it. And then you could always go back to the old one. So what I generally do with mine is keep updating the default boot environment and have snapshots of when it worked on Thursday or whatever to go back to, rather than building the new boot environment and then switching to it because I don't want to miss out on things that I changed or whatever. For packages, the other problem you have there is the package database that keeps track of what packages you have installed is in var.db package. If you have user local separate, then if you roll back to an older boot environment or switch to a newer one or whatever, if your database says you don't have that app installed, but it's there, then it's not going to get updated because package doesn't know it's installed, and it can cause problems that way. I think you can use package.conf to force the relocation of that so that it would live in user local or something to solve that. But it's another reason why user local is part of the root file system rather than being separate, because you'd have to get the package database to be located with the packages in order to ensure that you don't get a mismatch between what's installed and what the database says is installed.
But yeah, definitely work on this FreeBSD update boot environment script, because that could be becoming
because there's definitely advantages to the way you're proposing to do it, and that's the way other people do it as well. I think in the source tree under tools, there's one called, I think, Mbe Install, which is for when you're compiling from source, you can basically have the make install go to a new boot environment. And the advantage to this is you can do the make install, keep using your machine for 2 days, then reboot and get the new version. Obviously, if you install world a newer version over your running system, some of your tools are going to be out of sync or newer than the kernel, and that can cause all kinds of things to break. So yes, there are disadvantages to installing the newer stuff and then not rebooting immediately. And that's where having that be a separate boot environment makes sense. So basically, there's pros and cons to both ways, and ideally, we want the tooling to support either way, and also having possibly a separate user local. We do a separate user local and separate var.db on my machines at Scale Engine in the way I set up that image, but that's because it's not a desktop computer. It's done differently. And we're actually looking at changing that because we're looking at actually updating the packages as part of updating the operating system, basically shipping the packages as part of the operating system instead of having to run package upgrade on each server separately. Mostly because it's just a lot faster to ZFS receive the newer versions of the apps than it is to to run package upgrade, which is then going to fetch them single-threaded one at a time and then install them single-threaded one at a time versus just one big linear write in ZFS, and suddenly everything's newer. So it's not a bug, but hopefully that explains why it's done that way, but why it's not necessarily wrong to do it your way either. Hopefully soon, the BECTL utility will gain support for the concept of deep boot environments. Currently, your boot environment is one level. It's the / file system, and everything not in / is part of the stable data. But we want to actually be able to have sub data sets that are part of the boot environment. So for example, you can have user source be part of the boot environment, but a separate data set. So it'd actually be like zroot / default / user / source or whatever. And it would contain the source code that matches the kernel for that boot environment. And then every boot environment would have a different user source directory, and it would only mount the right one. That way you'd always have user source containing the source code that matches the kernel you're running, even when you switch boot environments. So that's the plan, and hopefully we'll get there. And then you could optionally have user local be a separate file system, but be part of the boot environment to get kind of the advantages of both.
Yep. Yeah, that would be nice. So there's definitely room for improvement still. And yeah.
And if you're interested in this boot environment stuff and taking it even further, I just finished my paper for Asia BSDCon, and I'll post that once I presented it. It'll be up on papers.freebsd.org, and it goes into a lot of detail on how you can structure stuff to do very interesting things and using ZFS to update your system instead of FreeBSD update. But what some of the missing bits and downsides to that are as well.
Okay. Yeah, I think that wraps pretty much everything up in our feedback and questions section, as well as our episode for this week. Remember, give us feedback at bsdnow.tv, to our show, to anything you want to see, blog posts, ideas, topics you did not find and want to have us cover, and then we'll have something for future episodes. See you next week.